So network devices by default generate the log messages, and these log messages can be used to keep the track of the events or the changes occurring in your network. Like if we take an example, if I go to the command line, so whenever you make any changes, currently I'm into my console screen of my device. So this is my console screen, let's say. And on this console screen, so whenever you make any changes, let's say I'm trying to shut down one of the interface. By default, it is in upstate. So whenever you shut down the interface, immediately you will see some messages appears here. Now this is like indication that this particular port S1 has been in shutdown state during this date, time, these options. And whenever I make the interface up, again the interface comes back again. And you see some messages here. So like that, you will see different types of messages in general on the console screen by default. Now these messages are typically referred as log messages, and these log messages are automatically generated, and by using these messages we can keep the track of the events occurring in your network. Like generally some of the log messages which help us, like device failure notifications, like you got a router and one of the interface fails or goes down, generates a log message. Or it can be some kind of other messages, like you're connecting to some router and you're establishing the EHRP neighborship and the neighborship fails, generates a log message. Or maybe you're connecting to some service provider network and you got some BGP connections and maybe the neighborship goes down, it generates a log message in general. Or you can also use a specific log messages, like you can do some kind of auditing where I can go to the router and configure the ACL to match a specific traffic, and I can tell the router to generate the log messages if any traffic matches that particular pattern, which can be used for some kind of auditing. Or even we can do some kind of troubleshooting also, it is useful. Like let's say you got some issue on the router, maybe the neighborship goes down and maybe the neighborship is flapping, or the VPN is not coming up, something is not working according to the requirement, and you just want to see what is happening in the backend. So we can enable the logging for the debug messages, and then we can see the backend messages, what is going on in the backend. So there's also another reason for generating the log messages and keeping a track of them. And of course we can also use it for forensic analysis, like for some kind of incident investigation. So let's say something occurred in your network, maybe some kind of attack, and you want to see some of these previous log messages which are generated on this particular device, where we can trace the victim and attacker at which point it actually occurred. So we do enable some logging messages. Of course the device generates some log messages to some extent, and we need to keep a track of those messages for multiple reasons. So now we got different options of logging, like we got a console logging option, VTY, local buffer, and external log servers. Now basically console logging means whenever you log into any device, like in this case I'm connecting to router 1 via console cable. Of course I'm using JNS3 to connect, but the default when you open up the console, it's almost like a console connection here. Like you connect your router to a physical console port and you access the router via console port, and by default logging is enabled on this particular port, and whatever the changes happening in your network, it will be by default showed on the console port. But by default these messages are not saved in general. So the console logging is by default enabled in all your router switches, and by default they send the log messages to the console port as I discussed just now, and hence only the users who are physically connecting to the router console port can view these messages. So if I'm not using the console, I cannot see these messages. So currently here the console access is on the router 1. Now by default these messages are not saved. Like even if you try to enable some kind of debug messages in the backend, you also see some kind of debug messages where the hello messages are sent for every 5 seconds. So those messages also will be shown if you enable the debug messages by using debug EHRP packets. Now, practically in the production networks, it's recommended to disable the console logging because large amount of logging messages or the outputs actually, while we are using the debug process, it's going to send to the console. So the large amount of log messages sent to the console by using some debugs, it will increase the unnecessary CPU load on the routers, and it can make your it can actually impact the control plane also sometimes, because it can even stop the routers from forwarding the packets or setting up the control plane, or maybe it loses some kind of neighborship issues may come if the router is receiving too many log messages. So that's the reason it's recommended to disable the console logging, because mostly in the production networks, console is something we don't use much, because most of the time we access the device via telnet or SSH via remote device, and we use only console for if there are any major issues, like you're doing some kind of password reverting, or if you are unable to log into the VTWL line, then you may need to troubleshoot maybe some issue with the connectivity and other things. So most of the time we don't use console, so it's recommended to disable the console messages by using no login console. So I can simply say no logging console, which is by default enabled. So once I disable this console, if I try to make some changes on the network, let's say my interface goes down, and you can see I don't see any log messages displayed here. Now the other option of the console is we can use something called buffer logging. Now, in the case of buffer logging, whatever the log messages generated, and these messages we can tell the router to save them in the local buffer memory or the local RAM. So this type of logging actually uses the router RAM for storing those log messages temporarily, and we can define the buffer size, the amount of bytes, actually how many bytes it should use to store those log messages. So buffer is nothing but the fixed size which we are going to allocate to generate the log messages, and the router is going to delete the old messages once it reaches the maximum size. And let's say the router is receiving the log messages anything above this memory what we allocated, automatically it will start removing the older entries. Now buffer logging is by default not enabled. We can enable by using a command called logging buffer, and if you want to verify the log messages, we can use something like show logging option. So let me just quickly enable this buffer logging here. So in the previous I disabled the console logging, so I'll try to re-enable the console logging, because at this point of time I want to see the log messages here. So we'll say logging buffer, and we can define what is the buffer size you want to allocate. Let's say I'm using just 4096 bytes. And if you want to verify, I can try generating some messages, like I'll try to shut down the interface, and then I'll say no shutdown, and also I'll try to shut down one more interface, let's say S1 by 0, because on the router 1 S1 by 0 interface I'm connecting to router 2, and I have pre-configured EHRP here. So most likely if I shut down the S1 by 0 interface, I should also see the interface goes down here. I think I didn't configure the EHRP, so I don't have EHRP configured. I don't have here, so probably you see the messages here, interface change state to down. I'll make it back up. And then now if you want to verify these log messages, we can use an option of show logging. So when I say show logging, you can see these messages just now, whatever generated just now, and the logging buffer size is 4096 bytes here.